As you've learned earlier in this course, you can use the group by clause in a select statement to arrange rows in groups, typically to support aggregations. However, if you need to group multiple sets in the same query, you can use the grouping sets subclause. A grouping set isn't a new concept. It's nothing more than the set of elements or attributes that you group by. For example, the set of attributes in any traditional group by query is a grouping set. SQL Server 2008 introduced a new option or subclause called grouping sets, which lets you define multiple grouping sets in the same query. Logically, a query with the grouping sets option produces one result as if you're using multiple group by queries and the union all operator. It's not that you couldn't achieve the same thing in the past, but with grouping sets option, you can write much less code and your query will be much more efficient and you will have more flexibility than in the past. So in this lesson, you will learn how to write queries using the grouping sets subclause, how to write queries that use rollup and cube, and how to write queries that use the grouping ID function. Before we learn how to use the grouping sets subclause, let's take an example and see how these queries can be done without using the grouping sets subclause. Let's say you need to query the orders table and return total quantity values for each customer, employee, and order combination, and for each customer and year combination, and for each employee and year combination, and also for the grand total. You can obtain all the result sets with 4 group by queries. But suppose you want to unify all 4 results into one. In other words, you want one result set unifying 4 grouping sets. One option to solve this is to use the union all set operation between the sets. And because all 4 result sets originally have different structures or schema, and set operations require that all input sets have the same schemas, you can use nulls as placeholders for the missing elements. The problem with this solution is that the code is lengthy and is very inefficient because the base data is going to be fully scanned 4 times. So to avoid all that lengthy code and inefficiency, grouping sets option in the group by clause has been introduced in SQL Server 2008. Using the grouping sets option, you simply list your desired grouping sets and it lets you write much shorter and more efficient code. The grouping sets subclause builds on the tsql group by clause and allows multiple groupings to be defined in the same query. Grouping sets provides an alternative to using union all to combine results from multiple individual queries, each with its own group by clause. With grouping sets, you can specify multiple combinations of attributes on which to group. Let's take a look at the syntax of the grouping sets subclause. In the select clause, you specify the column list, and in the from clause, you specify the source tables or views, use the group by clause, and in the grouping sets, you can specify one or more columns, and if you use the empty parenthesis, it will be aggregating all rows. Let's take a look at an example. This example uses grouping sets to aggregate on the category and customer columns as well as the empty parenthesis notation to aggregate all rows. And the result set will look something like this. With grouping sets, you can specify which attributes to group on and the order of those attributes. If you instead want to group on any possible combination of attributes, you can use cube or the rollup subclauses. Let's execute this query and see what the results will look like. Let's open a new query, paste the query that we just saw, and click on Execute. As you can see, there are some nulls all through the result set. And this may be because a null was stored in the underlying source or because it is a placeholder in a row generated as an aggregate result. For example, in this row, we can see that the total quantity has a valid value, but the category and customers are nulls. That's because it represents a grand total row, and the null in the category and customer columns are placeholders since neither category nor customer take part in the aggregation. So, now that we have seen how to use the grouping set subclause, let's see how to use cube and rollup subclauses. Like the grouping set subclause, the cube and rollup subclauses also enable multiple groupings for aggregating data. However, cube and rollup do not need you to specify each set of attributes to group. Instead, given a set of columns, CUBE will determine all possible combinations and output groupings, and ROLLUP creates combinations assuming the input columns represent a hierarchy. Therefore, you can think of CUBE and ROLLUP as shortcuts to grouping sets. Let's take a look at the syntax of the CUBE subclass. To use CUBE, append the keyword CUBE to the group by clause and provide a list of columns to group. And to use ROLLUP, append the keyword ROLLUP to the group by clause and provide a list of columns to group. For example, to group on all combinations of columns, category and customer, you can use the CUBE subclass just like we did in this query. And the output groupings will be category and customer, customer category, just the customer, just the category, and the aggregate of all the rows. And if you need to group on combinations of category, subcategory, and product columns, you can use the ROLLUP subclass like we did here. And the output groupings will be for the combinations of category, subcategory, product, category and subcategory, category, and finally the aggregate of all the rows. You need to know that the order in which the columns are supplied is significant when we are using the ROLLUP subclass. ROLLUP assumes that the columns are listed in an order that expresses a hierarchy. Let's execute these queries and see what the results will look like. Let's open a new query and paste the query that we just saw. And by using the CUBE subclass, the result set will have all the possible combinations of category and customer. Let's click on Execute, and it gives us all possible combinations of category and customer columns. Now let's change the CUBE subclass to ROLLUP and execute this query. Click on Execute, and it will assume that the category and customer are in a hierarchy and gives us all possible combinations. Now let's see what grouping ID function is and how to write queries using this function. As you've seen, multiple grouping sets allow you to combine different levels of aggregation in the same query. You've also seen that SQL Server will mark placeholder values with nulls if a row does not take part in a grouping set. But in a query with multiple sets, how do you know whether a null marks a placeholder or comes from the underlying data? And if it marks a placeholder for a grouping set, which set is it from? The grouping ID function can help you provide additional information to answer these questions. For example, let's take the query here, execute it, and see what the results will look like. Let's open a new query and paste the query that we just saw and click on Execute. At a glance, it may be difficult to determine why a null appears in a column. The grouping ID function can be used to associate result rows with their grouping sets. For example, as you can see from this result set, the grouping ID function returns a 1 when a row is aggregated as part of the current grouping set and a 0 when it is not. For example, if you take the row here, the group category is marked as 0 and group customer is also marked as 0, which means that this row is part of a grouping set of category and customer. So, now that you have learned how to use the grouping ID function, let's recap what we learned so far in this module. We have learned how pivoting data can be used in T-SQL queries and how to write queries that pivot data from rows to columns using the pivot operator, and how to write queries that unpivot data from columns back to rows using the unpivot operator. We have also learned how to group by different attributes in the same query using the grouping set subclass of the group by clause, and how to write queries that use ROLLUP and CUBE subclasses, and how to write queries that use the grouping ID function. In the next module, you will learn how to query SQL Server metadata.